I said in several slides that water can donate hydrogen ions and accept hydrogen ions. So it can behave as an acid or as a base. It's not particularly good at either, which actually is a good thing, because it means that it can easily react with acids or with bases, depending on what the other components it confronts needs. So if necessary, it will accept hydrogen ions, if necessary, it will donate them. So if a compound like water can react as an acid or as a base, then it seems to stand to reason that one molecule of water could react in an acid-base reaction with another molecule of water. Because if it can react as an acid or as a base, that means it can react with itself. We call that self-ionization in this case of water, or autoprotolysis in this case of water. So I'm going to ask you now to give me the product of this reaction. Let's declare, for example, that my first molecule of water is going to be the one that behaves like an acid. And the second molecule of water is going to be the one that behaves like a base. So if you imagine the first molecule of water is an acid and the second one behaves like a base, what would be the product of that reaction? Stop the video now, please. So here we've got the reaction of self-ionization, autoprotolysis of water. You have two molecules of water that react with each other and produce hydrogen ions, or hydronium ions if you prefer to use that name, and hydroxyl anions, or hydroxide ions if you prefer to call them. I told you that water is not very good at doing this, either being a base or an acid. So not a lot of water is going to, if you have a sample with water, only very small proportion of water is going to do that. Most of the water in the sample will be water compound H2O, covalent, the oxygen and the hydrogen is bonded. A tiny minuscule proportion will be engaged in this reaction, producing hydrogen ions and hydroxyl anions. At 25 degrees, the concentration of hydroxyl ions and hydrogen ions is 10 to the minus 7 moles per liter. And the concentration of hydrogen ions times the concentration of hydroxyl ions, 10 to the minus 7 times 10 to the minus 7 is 10 to the minus 14 at 25 degrees. We call that the ion product constant for water, Kw. So as you can see, it's a tiny proportion, and 10 to the minus 7 moles per liter of your sample will be hydrogen ions and 10 to the minus 7 hydroxyl ions. It's a tiny proportion. However, it's a hugely important, and at 25 degrees, that 10 to the minus 7 happens to be at 25 degrees. The number changes with temperature because they are, the substance will ionize more or less depending on how the temperature changes. However, even if it's a tiny number, it's a hugely important one because it gives sense to our whole concept of what we consider an acidic solution, a basic solution, or a neutral solution. That 10 to the minus 7. As I mentioned in the previous slide, that proportion of water which is ionized is tiny, but it's hugely important because it gives sense, it defines the way we define what an acidic solution is, a basic solution is, or a neutral solution is. What do we call a neutral solution? Well, we call a neutral solution something that looks like water in terms of the hydroxyl and the hydrogen ions it contains. A neutral solution is a solution in that you have the same amount of hydrogen ions that you have of hydroxyl ions, which is what happens with water. And at 25 degrees, that is 10 to the minus 7. So a solution that has 10 to the minus 7, the concentration of hydrogen ions and hydroxyl ions is 10 to the minus 7 moles per liter. We call that neutral. What is an acidic solution? Well, we call an acidic solution a solution that has more hydrogen ions than hydroxyl ions. So what would be more? Well, it would need to be a number larger than 10 to the minus 7. So what could be a number larger than 10 to the minus 7? Well, a number larger than 10 to the minus 7 would be, for example, 10 to the minus 6, or 10 to the minus 5, or 10 to the minus 4. So that is what we call an acidic solution. If you have a solution that has a concentration of hydrogen ions higher than what you would have in water, and in water is 10 to the minus 7, so a concentration of hydrogen ions larger than that 10 to the minus 7, you call that an acidic solution. What about basic solutions? Well, basic solutions are the ones that have more hydroxyl ions, or in this case, fewer hydrogen ions than water has. Hydrogen has 10 to the minus 7 moles per liter hydrogen ions. So what would be a basic solution? Well, it would have to be something that has a number which is smaller than 10 to the minus 7. And a number smaller than 10 to the minus 7 would be, for example, 10 to the minus 8, or 10 to the minus 9, or 10 to the minus 10. So, if your solution has a concentration of hydrogen ions the same as in water, 10 to the minus 7, you call that neutral. If your solution has more hydrogen ions than water would have, you call that acidic. And if your solution has fewer hydrogen ions than water would have, you call that a basic solution. So it is worth that, and that 10 to the minus 7 is specifically at 25 degrees, because that the ionic product of water at 25 degrees is 10 to the minus 14. That gives you a concentration of hydroxyl ions and a concentration of hydrogen ions of 10 to the minus 7. So that number 7 only holds at 25 degrees. At other temperature, or at room, what we typically call room temperature, at different temperatures, at 40 degrees or at 60 degrees or at 10 degrees, the number is slightly different, because the concentration of hydrogen ions and hydroxyl ions will depend on the temperature. However, the concept of neutral, acidic, and basic solutions will not change. And neutral solutions will be when you have a solution that has as many hydrogen ions as water has. An acidic solution, one that has more hydrogen ions. And a basic solution, one that has fewer hydrogen ions. And that is different to what we consider an acid or a base. Acid and base talk about the chemicals, the compounds you're looking at. A substance that donates hydrogen ions, a substance that accepts hydrogen ions, that donates electrons, that accepts electrons. An acidic and basic and a neutral solution talks about how the number of hydrogen ions of a solution compares to the number of hydrogen ions you would have in water. And it is unfortunate, because we talk about this is an acid, this is a base, and when you talk about an acid and base and a neutral compound, what you really mean is acidic solution, basic solution, and neutral solution.